Okay, so there's two lesson videos for 8M1L2. The other one talks very generally about the product and multiplication uh, uh, rules of exponents, so how you multiply exponents and how you divide exponents. This will focus a little bit more exactly on the lesson from Eureka Math. I'm going to go really quickly over the multiplication and division rules. Then I will move into one of the concepts where they talk about distribution and how that plays. It's a building block that they bring back into this lesson. And then third, I'm going to talk about going to give you talk about two of the homework problems and give you maybe a little bit of help how you might think about the problems that are very difficult. These homework problems are very difficult. If you just kind of look at the lesson and then you try and attach these homework problems are on a kind of a different level and really require some intense critical thinking. And so I want to give you some ideas about how you might think about some of these two of these problems and give you just maybe a little bit of a leg up. Okay, so without further ado, let's cut over and start talking about this lesson. Hopefully we can get through it in, we'll try and get through it in 20 minutes. Again, as always, if you understand what's going on with any part of the lesson, feel free to just fast forward to the part that maybe you're looking at. You don't need to sit here and listen for 20 minutes if this all makes total sense to you. But let me start off first. So again, first we're just going to talk about basically the multiplication and division rules for exponents. And I know that the title of this lesson is the multiplication of numbers in exponential form, but there's also division rules in here and some more advanced stuff where we talk about distribution and things, where we bring in some concepts from the past. So let's make sure that we understand everything that's going on in this lesson. So let's start off with just multiplication rules, and let's just remind ourselves of what we learned in lesson 1, which is like, x squared times x cubed, does that equal x to the 6th or x to the 5th? Well, if you break this down, you can say, well, x squared times x cubed is x times x is x squared, and x to the 3rd power is x times x, right? So this is our x times x times x, and this is our x times x. And so that is equal to, well, how many x's do we have multiplied? Well, that's x to the 5th. So the rule is when you're multiplying at powers, you add the exponents, which is counterintuitive because it seems like when you multiply numbers, you should be multiplying your exponents, but that's not true, and you can see that here. So you can always break this down. Break a problem like x squared times x cubed down into its base components. Like, what does x to the 2nd power mean? What does x to the 3rd power mean? And you can see that by rule it must be x to the 5th, because x times x times x times x times x has to be x to the 5th. So, but sometimes you don't want to break it down into its constituent components, x to the 2nd power, because what if you're faced with this problem? X to the 22nd times x to the 33rd power. Well, this is an example where I don't want to sit here and write x times x times x 22 times and then write it again 33 times. That's a pain in the you know what. So instead, let's just use the rule. The rule says you add the exponents. And so we're going to get x to the 22 plus 33. And so that's x to the 55th power. So this is the rule that we learned. And in class, you should have practiced this over and over. And many of the exercises teach you this in many different ways, So we'll stop there. That's our rule. Let's switch over. Let's cut to the division rule. The division rule, you build it the same way. Again, so let's just go back and let's say when multiplying, you add the exponents. So multiplication of powers goes with adding. So now let's look at division. And we build build the division rule the same way. So we say, well, x to the 5th divided by x squared. Well, or let's do it x to the 6th. X to the 6th divided by x squared. Well, you may say, well, 6 divided by 2 is 3, so x to the 6th divided by x squared might be x to the 3rd power, but let's write out the power rule. Let's write out what do we mean by powers, and then we're going to see the answer. It's going to become painfully obvious. Divided by x times x. And if you want to see it without variables, you could see it like this. 3 to the 6th over 3 squared would be 3 times 3 times 3 times 3 times 3. So we can take away all the variables and do this with just regular numbers too. Just the same. And if we look at this, we know from division that we can just do some canceling to find our answer. So we can cancel 3, cancel 3. And our answer now is 3 times 3 times 3 times 3, which is 3 to the 4th. Similarly, we could do our canceling here and go cancel, 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 cancel. And up here, we're going to have x to the 4th. And so our rule is we have to, when we're doing division, we have to subtract exponents. Right? Okay. And so we can do very complicated things like, or very difficult things like, say, x to the 66th over x to the 22nd. And that's just going to be by using our rule that says we subtract exponents. We get x to the 66th minus 22, and that equals x to the 44th. So that's kind of the first lesson that I wanted to teach you. Now this is, again, you should have been doing a lot of this in class in lesson 2, but I want to go to something that where things get a little bit more involved and make sure that we understand this. So let's get ourselves a new worksheet here. Let's see, now we have to go here, and then we have to get a new background that looks like this, and we're off and running. Okay, let's start with blue. Now, this is problem number 19 and 20 in the lesson. Number 19, number 20. And here they show you 2 examples where they want to make sure these are building blocks that you're going to need actually on one of the homework problems. And they introduce it. So we're sitting here talking about exponents, and then they throw back in this old concept of distribution. And I just want to make sure that we remember how to do this. When you're multiplying something, a number or a term, and you're multiplying it by two terms inside parentheses, you have to multiply that term by each piece on the inside. So I always like to draw the arrows, and so we have to multiply b times a, and so we get a times ab, and we move our plus sign here, plus b times b. And what's b times b? Well, b times b is b squared. So we get ab plus b squared. And that's I think that's number 19. And now number 20, they throw another thing at you that gets even maybe a little bit more confusing, but let's make sure that we understand this. And we can use distribution again. We're going to have to use it a couple times on this problem. And so we have, just like up here where we have one thing times another thing, here we have this whole first thing is kind of like that b. We can take this whole first thing and we're going to multiply it by a, and then we're going to take it and we're going to multiply it by b. And so let's see what happens when we do that. Well, a plus b in parentheses times a is a plus b times a. And then a plus b times b is a plus b times b. Well, we have another distribution problem. And remember, distribution can work with the a in front or the a in the back. So let's draw our arrows here. And then here we have a b that's multiplied by those things in parentheses. And so here we have a times a. Well, let's just do the shorthand right now. A squared, because that's a times a is a squared plus a times b, or b times a times b, same thing, plus b times a is another, well, that's a times b. And then b plus b times b is b squared, or b to the second power. And we're almost done. It feels like we should be done after doing two whole things, but we have to do a third thing because we have this and this, which are, these are like terms. So if I have one AB and another AB, this is 2AB. So I have a squared plus 2AB plus b squared. Okay, we're going to get into more of this later on in the year when we look at patterns like this where we have what they call a binomial, two things added together times another binomial, two things added together. You end up with like kind of 4 multiplications. Each thing kind of has to be multiplied by each other thing. And we can see that because we have to distribute by doing this distribution once in this problem and then doing the distribution again to get down to this second part. We end up with these 4 terms. And then we often have to end up combining like terms on the 2 middle terms. Often. They're not every time, but usually the case. So that's the second thing they just kind of threw at us here in lesson 2 to make things a little bit more confusing, perhaps, but really trying to integrate past learning with current learning and making sure that we're synthesizing everything we're learning here in algebra. So let's do the final thing. The final thing, well, no, I wanted to do problem number 31. So let's look at problem 31. And that was another kind of, maybe a little bit difficult type of problem. But let's just see if we can get through this one using some past rules that we knew from from 7th grade and stuff we learned today. So we have this thing 5 over x to the 3rd power times 3x to the 8th. Wow, this is crazy looking. Well, let's make sure that we can actually think of this. What would we have done if we had 5 over 2 times 6? What would we have done there? Well, we would have had to put our 6 and made this turn this into a fraction. So that would be 6 over 1 times 5 halves. And then we just multiply, and we can cancel first. This would be a 1, and this would be a 3, and we get 15 over 1, which would be 15. Here we do the same thing. We just have a lot more going on. So let's make this into a fraction, improper fraction. Whoops. 3x over 8 over 1 times 5 of x cubed. Let's just multiply these together. So 5 times 3 times x times 8, so this is all just multiplied. So if we multiply our numerator, we get 5 times 3 times x to the 8th. All of that over x cubed, x to the 3rd times 1 is x to the 3rd. And so that equals, well, 5 times 3 is 15, x to the 8th over x to the 3rd. Well, now we can look at, we want to look at what we have here. We want to do some canceling. So one way to do this is we'd say 15 times x 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 times at 1, 2, 3, 4, 5, 6, 7, 8 over x times x times x, and we cancel an x, cancel an x, cancel an x, and we have x cubed, what's left? We have that and this. So we have our 15x to the 5th. And we could have just look here. We could have used our quotient rule and said, well, this is the same thing as 15 times x to the 8 minus 3 equals 15 times x to the 5th. So we could have used our quotient rule. We could have expanded. Either way works great. And we're off to the races, and we're doing number 31. You can work on B and C on 31. They work exactly the same way. I encourage you to do it. Try those out. Maybe you did it in class. Maybe you understand this perfectly. Now what I want to do is I want to go and give you a little bit of homework help. And I want to do it on problem, just something for, I think it's problem 1. So let's take a look at that. Problem 1 asks you, so you've done all these problems and you've done a lot of what they call fluency. You've learned how to manipulate these exponents pretty well and these powers pretty well, but you haven't learned how to apply them. And in your homework, they're asking you to apply some of these problems. So let's see if we can make sense of like some help for problem number, I think it's problem number 1. So Bill, and I'm going to change it up a little bit. So I'm not going to give you the answer. So let's say Bill drops a ball from, 30 feet, and it bounces 3/4 that height each subsequent bounce. So it goes 30 feet. So the first time we drop it, it's going to drop. And we're going to call this 30 feet. And then it's going to bounce, and it's going to bounce 3/4 that high. So that's 3/4. And we're not going to do the math out because in the homework problem, this 30 becomes an x. So if the ball's going here, right, and then it bounces, it only goes 3/4 as high. Well, then it's going to come down 3/4 as high. So we're seeing how far this ball goes. Well, the next time it goes 3/4 of this height. Well, what is this height? Well, this is 3/4 of 30. So now it's going 3/4 of 3/4 of 30. Bounces that high. And then it comes down that same height. So I can rewrite it again. I'll write it again. 3/4 of 3/4 of 30. And then again, if it goes 3/4 of this height, it goes 3/4 of this height. Well, what is this height? Well, this height is 3/4 of 3/4 of 30. And then it falls that same height. So let's look at this. So this is the same height. These are the same height. So what is an expression that represents this? Well, this is 30 feet. And this is 3/4 of 30. And what is this? Well, this is 3/4 times 3/4. So this is 3/4 squared to the second power times 30. And so it does that. That's how high it goes up, and then it comes down that same amount. And then it does it again, but it's 3/4 to the third power times 30. And then it falls that same amount. And so on. And if it kept going, and going and going. You just have to keep writing this expression over and over. So that's some help that should get you part of the way on this next homework on one of the homework problems. And let's see, let's do one more. There's one other problem that I think you may need help with. So we'll take a look at that one. Wait, we need to do our background again. I like this background, this kind of yellow graph paper. Easy on the eyes. Okay, and the last problem says, well, if I have, let's just pretend I have 2,000 square feet. And every student gets 40 square feet. So I have this big lot of 2,000 square feet. And each student gets a 40 square feet block to, whatever, to play in. Well, how many students, so how many blocks, how many 40 square foot blocks fit in 2,000 square feet? Well, the answer is, right, you could probably see it. Pause the video, you can think about it yourself, but the answer is 2,000 divided by 40, which is equal to 50. 50 students, or 50, we'll just write 50 blocks. So the key is you answer by division. Now, let's say that I didn't represent it as 2,000 square feet. What if I instead said you have 2 to the 10th square feet space, and each block is 4 squared square feet. So I have this big space that's 2 to the 10th, and each block is 4 squared. These aren't even, but just pretend they are all even. The answer would be, well, how many blocks fit? How many blocks? Well, the answer would be, similarly to over here, I think you guessed it, 2 to the 10th divided by 4 squared. Well, I cannot divide exponents, but I can, what's the trick I do? I'm going to say, well, this is 2 to the 10th. 4 squared is 16. Well, 16 is equal to 2 times 2 times 2 times 2, which is equal to 2 to the 4th. So we have 2 to the 10th over 2 to the 4th, and that equals 2 to the 4th, 2 to the 6th blocks. Okay, so hopefully this was helpful homework help. Hopefully you are. Hopefully this was a useful. Hopefully this was a useful exercise for you, or a useful time that you spent with me. What I'd like you to do is, if you like this video, I'd like you to at least hit the like button on YouTube. If you have any questions or concerns, what I'd like you to do is take it forward and say, well, at minute 12 minutes, Mr. Lipscomb, I didn't understand when you did the example about distribution. And I can either answer that on typing it on as a response on the YouTube channel, or maybe I could do another video that can explain that concept to you. I would also encourage you to just tell me if you liked it or not. You can just use words. You can send me email at cowboy.lipscomb@gmail.com. But feel free just to comment on the video itself. Like it or don't like it. Thumbs down is fine. If this was a terrible, useless video, please tell me why if you didn't like it, because I'm here to just make it better. I'd like to do every lesson for all of 8th grade, and I'd really like to help you guys out. So, thank you. Your applause and your support is what makes me do this out of the goodness of my heart, because I love teaching math. All right, we'll see you next time.